In this lesson, we will use inverse matrices to solve systems of equations. We'll start by solving the system of equations 2x plus 5y equals 3 and x plus 3y equals negative 4. First, I look for the coefficient matrix, which here will be the matrix containing the numbers 2, 5 in the first row, 1, 3 in the second row. I name this matrix A. I next look for the variable matrix, which contains the variables of x, y here. I will name this matrix capital X. There may be some confusion with two x's. The convention is to use uppercase X for the name of the matrix containing the variables. Unfortunately, lowercase x is the most common name for a variable. By paying attention to context, you should be able to recognize which x is being referred to. So next we look for the constant matrix. The constants are the numbers to the right of the equal sign. Our constant matrix will be the 2 by 1 matrix containing the numbers of 3 and negative 4. We will name it B. Notice that AX is equal to B here. If we take row 1 of the matrix A times the column of matrix X, we have 2x plus 5y, which is equal to 3, the first number in our B matrix. And if we take the second row of A, we have 1 times x plus 3 times y, which is equal to negative 4, the number in the second row of the matrix B. So AX equals B, and we will use that fact and some things we know about matrices to solve for x here, and then we will be able to solve for the xy variables. So AX equals B. We'll start by multiplying on both sides of our equation by A inverse. A inverse times AX is equivalent to A inverse times A times X. Matrix multiplication is associative. A inverse times A is equal to the identity matrix I. I times X is equal to X, so I have X equals A inverse B, and we've solved for X here. Okay, so A, which is equal to 2, 5, 1, 3 here, we found in the last video that the inverse of this matrix is the 2 by 2 matrix, 3, negative 5 in the first row, negative 1, 2 in the second row. So if we want to solve for X, we take A inverse times B, and I will multiply these two matrices together, find that my matrix X is equal to the 2 by 1 matrix 29, 11. The matrix X represented the variables of x and y, so we have found that x equals 29 and y equals 11 is the solution to our system of equations. Next, we'll solve a system of 3 equations and 3 unknowns, starting with finding the coefficient matrix A. So the first row of A will be 1, negative 1, 1. The second row, 0, 2, negative 1. The third row, 2, 3, 0. Our matrix X this time will contain the variables x, y, and z. Our constant matrix B will contain the constants 2, 7, and negative 4. In the last video, we also found that the inverse of this matrix A was equal to a 3 by 3 matrix with first row of 3, 3, negative 1, second row of negative 2, negative 2, 1, third row of negative 4, negative 5, 2. To solve for x here, for our variables, we take A inverse times B. Multiplying these two matrices together, I will have the 3 by 1 matrix of 31, negative 22, negative 51. Recalling that my matrix X is representing the variables x, y, and z here, I have found that x equals 31, y equals negative 22, and z equals negative 51. This is the solution to our system of equations. Try on your own. Solve using an inverse matrix the system of equations 2x plus 5y equals negative 2 and x plus 3y equals 1.